Hello and welcome to Couchbase Connect Online 2020. My name is Balaji Narayanan. I work as a solutions architect on the Center of Excellence team at Couchbase. About me, cloud computing is my passion. I have more than 15 years of experience in enterprise application design, development, and implementation. I have extensive experience designing solutions to implement cloud architecture using AWS, Azure, and GCP cloud platforms. Prior to joining Couchbase, I was engaged with Microsoft building IaaS and PaaS platforms for Azure Cloud Native Services. In this session, we'll do a deep dive to learn how the Couchbase cluster can be publicly accessible using Couchbase Autonomous Operator with external DNS solution. When it comes to managing Kubernetes cluster, one of the critical aspects, or I would even say one of the topical subject, is networking. If you get the networking right, then you have got everything right to run the Couchbase database on the Kubernetes platform. In this session, I will show you how the external DNS solution helps to dynamically manage the external DNS records from within a Kubernetes cluster. Now let's get started. This is the agenda for today's session. First, we will do a sneak peek on the Autonomous Operator overview, where we will see the various enterprise-grade features of Operator, and we will then look at the Autonomous Operator architecture. We will then see what are the different networking options when it comes to accessing Couchbase cluster deployed on a Kubernetes platform using Autonomous Operator. We will then focus on why do we need to expose Couchbase cluster on a public network. And finally, we will see how Kubernetes external DNS solution helps us to access Couchbase cluster on public network. Finally, we'll get into the action, right? So I will do a quick demo where we will deploy and access Couchbase cluster on public internet using the Couchbase operator with external DNS. Now let's take a quick overview of the Autonomous Operator. Implement DevOps through autonomous operations. So talking about Couchbase Autonomous Operator, as the name autonomous goes, it's self-service, self-healing kind of operations, right? So the intention here is to reduce the operational complexity of provisioning and managing the Couchbase cluster on Kubernetes. The Couchbase operator enables the customer to run Couchbase on any infrastructure on any cloud. Basically, it removes the infrastructure lock-in and also enables the cloud portability, right? So with Couchbase native integration with Kubernetes, we have automated the operational aspects like provisioning, scaling, managing, and upgrade, right? So, and all of these operations can be autonomous now using the Couchbase operator. And these are the operational best practices that basically drives the customer focus towards the operator. The goal here is customer wants the flexibility in terms of where they want to deploy from one cloud to another cloud, right? So with Kubernetes platform, they can now be able to move around multiple clouds. And with Couchbase XDCR feature, they can migrate data from one cloud to other cloud, right? So, and when it comes to cluster configuration, the operator pretty much supports every enterprise feature, like supporting persistent volumes, server groups for high availability, cross data center replication, TLS and certificate rotation, role-based access control for security, backup and restore, and especially when now you can monitor any number of Couchbase clusters running on the Kubernetes platform using Prometheus monitoring. So operator pretty much covers every enterprise feature, right? Couchbase Autonomous Operator architecture, right? So as you can see here, the primary and the main component when it comes to the Kubernetes cluster is the Kubernetes master. So the Kubernetes master is a main node responsible for managing the entire Kubernetes cluster, right? So it handles the orchestration of the worker nodes. And you use kubectl, the CLI to interact with the master node of Kubernetes, right? And as you can see, it has three main components that is responsible for communication, scheduling, and controllers, right? So API server. So talking about the API server, the Kube API server interacts with API. And we can say it's front end of the Kubernetes control plane, right? And then comes the scheduler. So it actually watches pods and assigns them to run on specific hosts, right? So that's the work of scheduler. And then the controller manager. Controller manager runs various controllers in background, which runs different tasks in Kubernetes cluster, right? And then you have etcd database. So it's the key value store that stores Kubernetes cluster data. And you have the kubeproxy, which is a process that helps to add network policy and load balancer for the services in a single worker node. So basically the worker nodes can be exposed to internet via kubeproxy, right? So it helps us to add the network proxy. So that's about the Kubernetes master. And then comes the operator. So the operator is composed of two components, a per cluster dynamic admission controller and a per namespace operator, right? So let's talk about the dynamic admission controller. So the admission controller allows us, allows the custom resources to be modified and checked before even a resource is accepted and committed to etcd database, right? So running the admission controller allows us to add sensible defaults to Couchbase cluster configurations, thus minimizing the size of specifications, right? The size of the cluster definitions. So let's consider a case where you want to create a resource on the Kubernetes cluster, right? So what happens in this case? A client connects to the Kubernetes API and it sends a request to create a resource, right? The API then forwards the request to the mutating endpoint of the admission controller. So the mutating webhook is actually responsible for altering the resources. So when I say altering the resources, applying default values, for example, right? So it will then decide to accept or reject the create request. So what happens next is the API then forwards the request to the validating endpoint of the admission controller. So the validating webhook is responsible for validating specification constraints, basically, more than what is actually offered by JSON schema validation provided by the custom resource definition, right? So it will then decide to accept or reject the create request. So once all admission checks have passed, the resource is persisted in the etcd database, right? Then finally, the API then responds to the client, that the create request has been accepted. So this is the life cycle of the admission controller, right? And talking about the operator watches for events related to Couchbase cluster resources, right? The operator, it reacts to creation events by provisioning new resources and initializing the Couchbase cluster. So during the lifetime of the Couchbase cluster, the operator continuously compares the state of the Kubernetes resources with what is requested in the Couchbase cluster resources, right? It then reconciles as and when required to match exactly what was requested. So the operator is also Couchbase server aware. So it can, so it can detect and fix faults that would not otherwise be, even visible to the Kubernetes. So all resources are, resources are linked to their parent Couchbase cluster resource with owner references, right? So if a Couchbase cluster is deleted, this will actually cascade and delete all child resources, right? And as you can see here, we have different controllers, right? So pods. So pods are used to create Couchbase server instances. And we have services. So services are used to establish DNS entries for communication with Couchbase server endpoints, right? So per node services can also be used to provide addressability to clients operating outside the Kubernetes cluster. And we have config maps. Config maps are used to persist, state required per cluster, right? And then you can see pod disruption budget. So we call it as PDBs. So PDBs are used to control Kubernetes rolling upgrades, right? So this actually prevents Kubernetes from draining nodes in a way that would result in data loss. And then you have jobs and cron jobs that are used to restore data to and backup data periodically from a Couchbase cluster, right? And then you have persistent volume claims that are used to provide high performance disaster recovery in the event of a Couchbase server crash, accidental deletion or data center failure, right? So they are actually used as packing storage for Couchbase backups. So persistent volume claims related to Couchbase backups are not associated with the parent Couchbase cluster resource, right? And are not deleted when the parent is deleted. So that's about the operator. And then comes the Couchbase cluster, right? So in this case, as you can see, the Couchbase database, runs on the worker nodes in the Kubernetes cluster, right? So these nodes are controlled by master, Kubernetes master via kubelet process, right? So pods are used to create Couchbase server instances and are connected with the persistent storage, as you can see here. And then you can see these monitoring resources under monitoring namespace that basically helps to monitor the Couchbase clusters running on Kubernetes platform using Prometheus monitoring. So this is the Couchbase Autonomous Operator architecture that describes different components involved, right? Now we will take a look at the networking options. So the first option is, when it comes to networking, is intra-Kubernetes networking, right? I would say intra-Kubernetes networking is the simplest option, and it actually allows clients running in the same Kubernetes cluster as that of the Couchbase server instances, right? So the client can actually use endpoint DNS entries to connect to individual Couchbase nodes, and stable service discovery is provided by service records, right? So, and you can also use TLS to secure communications here. And as I said, so this is the simplest networking option available, right? So, where it basically allows clients running in the same Kubernetes cluster as that of the Couchbase server instances. Next is inter-Kubernetes networking with forwarded DNS option. So talking about inter-Kubernetes networking, it basically allows clients to, connect to Couchbase server instances in a remote Kubernetes cluster, right? So it uses the DNS service offered by the remote Kubernetes cluster to provide addressing. So basically, a local DNS server is used by Couchbase server and clients to actually forward DNS requests for a remote namespace to a remote Kubernetes cluster, right? So any DNS server that supports forwarding of zones to remote DNS servers can be used here, but we actually recommend core DNS, which is the de facto cloud native standard, right? So, and this method of communication can only be used if clients in one cluster can communicate with pods in another, right? So it uses a concept called router networking. So talking about router networking, for example, Amazon AWS use the VPC CNI plugin, right, to actually create router networks that can be peered together. And for example, Google GKE allows multiple Kubernetes clusters in the same virtual private cloud and has router networking by default, right? Again, even in this case, the client can use endpoint DNS entries to connect to individual Couchbase nodes. And stable service discovery is provided by the service records, right? SRV records. Again, the communication here can be secured using TLS as well. So this is about inter-Kubernetes networking with forwarded DNS, which uses a concept called router networking. And next option is public networking with external DNS. And this is our topic for today, right? So public networking allows clients to connect to Couchbase server instances from anywhere with an internet connection. So actually, external DNS is a service that can be run in a Kubernetes namespace, right? So it allows services to advertise load balancer service, public IP addresses, with public dynamic DNS services, right? So basically, a publicly addressable cluster uses public networking with external DNS strategy for its network architecture, right? So Couchbase cluster nodes are exposed using load balancer services that have public IP addresses allocated to them. So the external DNS controller is actually responsible for managing dynamic DNS records in a cloud-based provider to provide stable addressing. And this is the public networking with external DNS option, right? So those are the three networking options available. Now we will take a look at why we actually need to expose Couchbase on public network, right? So why do we need to do that? Pretty common use cases are functions as a service, right? So increase in cloud exposure, basically among enterprise and software startups, is becoming very common nowadays, right? And in most of the use case, function as a service is being used for their application needs, right? So function as a service basically provides a platform that helps customers to develop, run, and manage application functionalities, right? So with no time wasted in building and maintaining the infrastructure that is typically associated with developing and launching an application, right? So that's a benefit of function as a service. So pretty common services available for serverless computing are AWS Lambda, Azure Functions, and so on, right? So these services are created on demand and can scale your code instantly to handle the required workload and to provide high availability, right? So while using function as a service capabilities for serverless computing, it would require a database connection for most of the use cases, right? So considering the fact that these offerings operate on the public internet, will also require a connection to a public database. So in this case, establishing private VPN tunnels between these services may be difficult or even impossible, right? So function as a service is a pretty common use case, where you need to expose Couchbase on public network, right? So next is cross data center replication. So every customer would always want to ensure high availability, right? So high availability, disaster recovery, and flexible global replication that can scale and evolve with your business, right? So and for this communication to happen, you might need a connection on the public network, right? And next is database as a service platforms. So while using a fully managed service for your database needs, would also require connection over the public network, right? So for your it needs a connection over the public network for your client application to bootstrap with the database. So that's a pretty common use case as well. And as you see here, all of the above use cases share a common goal, right? So what is that goal? So they allow clients to access the database instance without having to establish a VPN to a Kubernetes instance, right? So that is the common goal here. So this is why we need to expose Couchbase on public network. Next is the Kubernetes External DNS solution. So let's see what is the problem statement here, right? You probably would have created many Kubernetes deployments, and typically you expose your deployment to the internet by creating a service with type load balancer, right? So depending on your environment, this usually assigns a random publicly available endpoint to your service that you can access from anywhere in the world. But dealing with IPs for service discovery isn't that easy. So what you do is you register the IP with your DNS provider under a better name, most likely one that corresponds to your service name, right? So if the IP changes, you update the DNS record accordingly. You would also use ingresses to allow external traffic into your cluster, right? So as you can see here, through ingress, you can tell Kubernetes to route traffic to different services based on certain HTTP request attributes, for instance, the host header, right? But again, there's nothing that actually makes clients resolve those host names to the ingress IP address, right? Again, you normally have to register your entry with your DNS provider. So what happens here is, like, this involves a lot of manual configuration of Kubernetes resources and also the DNS records at your DNS provider. So which can be a time consuming and and an erroring process, right? So this can soon become a snag as your application grows in complexity. And also when the external IP changes, it is necessary to update the DNS records accordingly. So, this is actually the problem statement here, right? So now let's take a look at the solution here. So, it's basically, inspired by Kubernetes DNS. So when I say Kubernetes DNS, it is Kubernetes cluster internal DNS server, right? So inspired by the Kubernetes cluster internal DNS server. So sig-network team, right? So special interest group network team came up with the external DNS solution, right? So we will talk more about the sig-network team in the next slide. But talking about the external DNS solution, so external DNS, makes Kubernetes resources discoverable via public DNS service, right? So like kubedns, it retrieves a list of resources like services, ingresses, etc., like from the Kubernetes API to determine a desired list of DNS records. So unlike kubedns, it's not a DNS server itself. Your Kubernetes DNS is not a DNS server itself, but merely configures other DNS providers accordingly, right? So example, AWS Route 53, or Google DNS. There's a list of external DNS solution providers that we will take a look, in the later section. So in this case, what external DNS sets to achieve is in an ingress situation where you have an ingress controller and you have services lined up behind the ingress controller. You don't actually get an out of the box experience in setting up the external DNS records like A records in your DNS provider, right? So I get a public IP address with a load balancer, and under Kubernetes, I want to tie that public IP to a DNS record. So as it discovers, it discovers a service or ingress created, or updated, the external DNS controller will update the DNS records pretty much instantly, right? So it updates the DNS records pretty much instantly in your cloud DNS provider. So the same is true when you actually delete the service, right? So when you delete the service, the external DNS controller will reconcile and will delete the DNS record for that service in your cloud DNS provider. So it is pretty much instant, right? So that's how Kubernetes external DNS solution, approaches this problem, right? Provides a solution for this problem. As I said, Kubernetes network special interest group, right? So there are special interest groups available who are responsible for maintaining various components on the Kubernetes platform. sig-network is responsible for the components, interfaces, and APIs which actually expose networking capabilities, right? Capabilities to Kubernetes users and workloads. So sig-network also provides some reference implementation of these APIs. For example, kubeproxy as a reference implementation of the service API, right? And this team is actually responsible for maintaining number of things, right? So networking, control plane, and data paths, network service abstractions, service discovery, service load balancing, right? And services APIs for defining and grouping networking endpoints, and ingress APIs for defining L7 load balancing, and integration points with networking implementations like CNI integration, APIs for defining network policy, and cluster DNS, network security and identity, and these are the things, right, that the sig-network team is responsible for maintaining. And you can refer to the link, to the link below, to learn more about the sig-network team, right? And you can also see how you can contribute, to this team as well. our autonomous operator works with Kubernetes External DNS, right? So, while deploying the Couchbase database using the public networking with external DNS strategy for its network architecture, so Couchbase cluster nodes are exposed using load balancer services, right? So that have public IP addresses allocated to them. So then the external DNS controller will then be responsible for managing dynamic DNS records in a cloud-based provider to actually provide that stable addressing and a secured communication using TLS, right? So this is how autonomous operator works with external DNS, Kubernetes external DNS solution. And as I mentioned earlier, these are some of the external DNS solution providers. I have only listed a few top providers here, but there are more than 20 providers. You can actually refer to this link to know, more about the different external DNS provider and what is the status of each provider, right? When I say status, whether they are in alpha, beta, or stable status, and based on that, you can actually choose your external DNS provider. External DNS deployment, right? So this is an example of how the Couchbase Autonomous Operator with external DNS architecture is going to look like. And we will be exploring these resources during our demo, right? So in this case, as you can see, we will deploy the EKS cluster, and this is the EKS control plane where you will have the Kubernetes master node running, and then you will have these three worker nodes in three availability zones, and each node attached with the persistent storage. And you have the Couchbase operator and the external DNS controller deployed on the worker nodes, and then your Couchbase cluster nodes are actually exposed using the load balancer services that have public IP addresses allocated to them, right? So the external DNS controller will then be responsible for managing dynamic DNS in a cloud-based provider to provide stable addressing with secured communication using TLS, right? So actually, the external DNS deployment just involves simple steps, right? So and we will be taking a look at these steps now. Right? Let's take a look at the steps involved in the external DNS deployment. So at this point, it is basically, it is assumed that you have already deployed the operator in a namespace, and the next thing you need to do is to install the external DNS controller, right? So the external DNS controller must be actually installed before the Couchbase cluster, as the operator will actually wait for DNS propagation, before creating in Couchbase server pods, right? So this is because clients must be able to reach the Couchbase server pods in order to serve traffic and prevent any application errors, right? As I said, the very first step in the external DNS deployment is creating a service account for the external DNS controller in the namespace where you will be installing the operator. So this is the first step involved in the external DNS deployment. The second step is creating a role, right? The external DNS controller requires a role that provides the ability for it to poll for resources and look for DNS records to replicate into the cloud DNS provider, right? So while defining the role, you will actually mention the various resources and the actions allowed on these resources. Now you'll be creating a role binding. You need to link the external DNS role to the service account by creating a role binding, right? By creating a role binding. So you create a role binding for that. And the last step is to deploy the external DNS, right? One thing you have to focus here is to update some of the values here specific to your deployment, right? The service account name, right? So the service account name attribute ensures external DNS pods are running as the service account we set up, right? So this grants the controller permission to poll resources and look for dynamic DNS records. And Next is the domain filter attribute. The domain filter attribute tells external DNS to only consider, consider dynamic DNS entries that are actually associated with the DNS entries related to our, in this case, balaji.acloud.guru domain, right? And then we have the TXT owner ID attribute, that actually tells external DNS to label TXT management records with a string, very unique to the external DNS instance, right? So external DNS uses TXT records to record metadata, especially ownership information, right? Ownership information associated with the DNS records it is managing. So if the balaji.acloud.guru domain is used by multiple instances of external DNS, without specifying any ownership, then they would actually conflict with one another, right? And next is the CF_API_key attribute that is actually used by the Cloudflare provider to authenticate against the Cloudflare API. So in this case, we'll be using Cloudflare as our DNS provider, right? In our demo today. And next is the CF API email attribute that is actually used by the Cloudflare provider to identify what account to use against the Cloudflare API. And next, is the demo. Before we begin, there are a few important prerequisites that are required for this demo. You need to install and set up kubectl on your local machine. Kubectl is a command line interface, for running commands against Kubernetes clusters. And then you need to install the latest AWS CLI. The AWS CLI is, again, a unified tool that enables you to interact with AWS services using commands in your command line shell, right? In this case, we'll be using AWS CLI to actually communicate securely with the Kubernetes cluster running on AWS. And then you have to deploy the EKS cluster, right? In this demo, we will be deploying the EKS cluster in the US East 1 region with 3 worker nodes in 3 availability zones. You will need a public DNS domain. The domain can be purchased from a registrar like GoDaddy or AWS Route 53, right? So for this demo, I'm using my own registered GoDaddy domain, balaji.acloud.guru, right? So that's a domain we'll be using in the demo. And finally, you will need an external DNS provider. So in this demo, we'll be using Cloudflare as our external DNS provider. And if you plan to use Cloudflare as your external DNS provider, then you will need to create a Cloudflare account and add the DNS domain to the Cloudflare account. That being said, now let's get into the action, right? So let's get started with the demo. As I've already mentioned, we need to get the prerequisites done first. So I've already installed all the required tools. In this case, I've installed kubectl, I've installed AWS CLI, and I've deployed EKS cluster in US East 1 region with 3 worker nodes in 3 availability zones. So now let's take a look at that first. So you can do that by typing kubectl get nodes. As you can see, we have 3 worker nodes deployed as part of the EKS cluster. And you can also say kubectl get nodes option wide. And this will give you more information like internal IP, external IP, kernel version, and so on about the worker nodes. So now we have the EKS cluster up and running. So the next step is to deploy the Couchbase Autonomous Operator. So the first thing to do as part of the operator deployment is to download the operator package. So you can download the latest Couchbase Autonomous Operator package and unzip it to the local machine. So you can do that by going to the Couchbase downloads page, and you can go to Couchbase Autonomous Operator with Kubernetes section. And now you can select the required OS and version, and then download the operator package. In the interest of time, I've already downloaded the operator package. So as you can see here, the operator package contains YAML configuration files and command line tools that you will use to install the operator, right? So the next step is to install the custom resource definition. as you can see here, we are going to use the crd.yaml file to install the custom resource definitions that basically describe the various Couchbase resource types, right? So we can go ahead and do that now. So now we have installed the custom resource definitions for all the Couchbase resource types, right? The next step is to install the dynamic admission controller, right? You can do that by using the cb op-config tool. So go to the bin directory, and then you can find the cb op-config tool here. So I'm going to use this tool to install the admission controller. So in this case, I mentioned no operator. So I'm just going to install the admission controller in the default namespace. As you can see, we have now deployed, the admission controller. We can verify the deployment by saying kubectl git deployments. So as you can see here, the admission controller has been successfully deployed. So the next step is to create a namespace. So as you know, namespaces are a way to allocate cluster resources and also set network and security policy between multiple applications, right? So we will create a unique namespace called demo to deploy the operator, and later we will use the demo namespace to deploy the Couchbase cluster, right? So I'm going to go ahead and create a namespace called demo. So let's go and check. So as you can see here, we have now successfully created a namespace called demo. And the next step is to configure TLS. So the operator, ensures you configure your Couchbase cluster securely, right? So if the operator, detects a cluster is being exposed on the public internet, it will enforce TLS encryption. So before we generate TLS certificates, we need to determine, what DNS domain that the Couchbase cluster will be in, right? So we can use our balaji.acloud.guru directly, but then it can only ever be used by a single Couchbase cluster. So what we can do is we can create a subdomain called cbdemo.balaji.acloud.guru, right? So, so as you see here, the important aspect to focus while creating TLS certificates for Couchbase cluster is your subject alternate name. So as you can see here, I've created a SAN record based on my subdomain. And so in general, wildcard DNS name, star.cbdemo.balaji.acloud.guru will handle all public DNS names generated by the operator, right? So this needs to be added to the Couchbase cluster certificate. So, and we will use the easy RSA to create the TLS certificates. So in the interest of time, I've already created the TLS certificates for the Couchbase cluster. So now we will go ahead and configure the TLS. So when I say configure TLS, we'll be creating a secret for server and a secret for the operator. So server secrets need to be mounted as a volume with the Couchbase server pod with specific names, right? So the certificate chain must be named chain.pem and the private key as pkey.key. So now we will go ahead and create a server secret using the chain.pem and pkey.key, right? So I'm now created a secret for the Couchbase server. So now we will go ahead and create the secret for the operator, right? So the operator client secrets are read directly from the API, right? So it expects only a single value to be present. So that's ca.cert, as you can see here. So this will be the top level CA, which is used to authenticate all TLS server certificate chains, right? So now we'll go ahead and create the operator secret. There you go. So now we have created the secret for the operator. So that's about configuring the TLS. Now, the final step is to install the Couchbase operator, right? So now let's deploy the operator in the demo namespace. So to do that, we'll use the cb op config tool. So we'll cd into bin. And now we will use the config. In this case, I will say no admission in, so that it will go ahead and deploy just the operator in the namespace demo. So as you can see, it has now deployed the operator. So you can now check the status of the operator deployment, right? So you can do that by saying kubectl get deployments namespace demo. So as you can see, the Couchbase operator has been successfully deployed. And we can also check the status of the operator pod. And the Couchbase operator pod is also successfully up and running, right? And you can also check the logs, to confirm the, that the operator is up and running, without any issues, right? So we'll just copy the operator pod name here. There you go. So it looks good. And now we have now deployed the Couchbase operator, right? So the next thing to do is to deploy the external DNS. So before we do that, I just want to go to the Cloudflare account. So this is the DNS provider that we are going to use in our demo today. And I'm going to go and click on DNS to show that we don't see any DNS records related to the Couchbase server here, right? So, and now we will go ahead and deploy the external DNS. The first step in the external DNS deployment is to create a service account, right? So I'm going to go ahead and create a service account named external DNS. So the next step is creating a role, right? So the external DNS controller actually requires a role in order for it to be able to pull, resources and look for DNS records to replicate into the DNS provider, right? So this is the external DNS role definition file that I'm going to use. As you can see, these are the resources, and these are the action that you can perform on these resources, right? So So I've created the role now. And the next thing to do is to create a role binding to link the external DNS role to the service account, right? So this is the role binding definition file that I'm going to use, which will actually link the external DNS role with the service account. So we have now created the role binding. And the last step is to deploy the external DNS, right? So before we do that, we need to make sure that we update the values specific to your deployment, right? So in this case, so this is the external DNS deployment definition file, and so the important attributes to look at is the service account name. So as you can see, I've mentioned external DNS, which is nothing but the service account that we have created. And the next thing to note is the domain filter, right? So this argument tells external DNS to only consider DNS entries related to balajiacloud.guru domain, right? And the next is the text owner ID. So this argument tells external DNS to label text management records with a string unique to the external DNS instance. In this case, I'm using a unique value, which is cb-op-e-dns-demo. And next is the cf_API_key and cf_API_email. So in this case, we will be using Cloudflare as our external DNS provider. So to get your Cloudflare API key, you can go to your Cloudflare account and click on Overview. And you can scroll down and click on this Get Your API Token. And click on API Tokens. And now you can click on View. As soon as you click on View, it's going to ask password for your Cloudflare account, and as soon as you enter your password for the Cloudflare account, it's going to display the API key, and you can use that API key in your external DNS definition file. And finally, the Cloudflare API email, right? So this variable is used by Cloudflare provider to identify what account to use against the Cloudflare API. Right, so now let's go ahead and deploy the external DNS. So I've created the external DNS now, deployed the external DNS, and you can check the status of the external DNS deployment, saying kubectl git deployments. So as you can see here, the external DNS deployment is successful and is up and running. You can also go ahead and check the external DNS pod. So the external DNS pod is also up and running. And we can also go and check the logs to confirm that the external DNS is up and running without any errors, right? So just copy the external DNS pod name. So as you can see, it looks good. So now we have now successfully deployed the external DNS, right? And so the next step is to deploy the Couchbase cluster, right? So to deploy a Couchbase cluster using the operator, all you have to do is create a Couchbase cluster definition that basically describes what you want the cluster to look like, right? So like the number of nodes, and then push the cluster definition into Kubernetes. So in this case, this is the cluster Couchbase cluster definition file that I'm going to use to deploy the Couchbase cluster. So this, as you can see, I've mentioned the server secret here, operator secret, and the DNS domain. So this cluster definition will actually deploy the Couchbase cluster with 3 data pods across 3 different availability zones using persistent volumes, right? And I'm going to go ahead and deploy this now. There you go. So we have now deployed the Couchbase cluster, and we can now go and verify the deployment, right? So we can see. So basically, to check the progress, you can add the watch argument. So in this case, you can see -w, where it will check the progress of the pods creating, right? As you can see here. And you can also go and check the Couchbase operator logs. And this is going to take a minute or so. As you can see, we now have 3 Couchbase cluster pods hosting the services as per the Couchbase cluster definition, right? And we can also, let's make sure we check the external DNS logs to see if the DNS records for the Couchbase pods are being created, right? So as you can see here, it has created the DNS records for the Couchbase pods. And at this point, you can also go check the DNS page by logging to your Cloudflare account. And as you can see here, you can see the CNAME and text records added by your external DNS provider. So it's pretty much instant, right? And so now you have a publicly accessible, addressable cluster that you can start using it, right? So the Couchbase Web Console can be accessed through an exposed load balancer service of a specific pod. In this case, let's go ahead and try to access the Web Console. There you go. So you can give the name and password. So as you can see, it has created 3 data pods in 3 availability zones based on the cluster Couchbase cluster definition, right? And that's pretty much it. And now I just wanted to go through some of the troubleshooting steps, in case if you face any issues during your external DNS deployment, right? So let's take a look at some of the troubleshooting steps. So DNS is not instantaneous, right? So it takes time for records to appear, and it takes time for modifications to propagate as TTLs expire, right? So to check that DNS is as expected, we need to first take a look at the expected DNS names. So to do that, what we can do is we can go ahead and list the service. So as you can see here, all the Couchbase cluster nodes are exposed using load balancer service that public IP addresses allocated to them, right? So now let's grab one of the service here. So as you can see here, this is the calculated DNS name, right? And you can check if this is the expected DNS name, and so that's the first thing to check. And then you also need to make sure that the requested ports are listening, right? So we can check that the TLS enable admin port in this case it's 18091. So that port is listening, and also we can establish a TCP session on that port, right? So let's check that. So how do you do that? So let's say and the port is 18091. There you go. So as you can see, the connection to the DNS name cb-edns-0000.cbdemo.balajiacloud.guru is succeeded, right? So that looks good as well. And the final thing to do is to establish whether the TLS is working as expected using the CA certificate, right? So how do you do that? Is you can say open SSL, and you can give the host and the port, and also a path to your CA cert. There you go. So so this ensures that your TLS is working as expected using the CA cert. So those are the troubleshooting steps that you can perform if you face any issues during your external DNS deployment. That being said, and that's pretty much I have for the demo. And these are some useful resources. I've written a blog on this, and you can access this blog using the link here. And I've pretty much documented each and every step involved, right? Each and every step that we discussed in this demo. And it's pretty straightforward and easy to implement. Simple steps to deploy the Couchbase cluster using the autonomous operator with external DNS solution. And I've also listed other references here. You have these other links to Couchbase autonomous operator documentation, external DNS, and Kubernetes documentation, right? Hope you enjoyed my session. Hope you are looking out to actually explore Couchbase Autonomous Operator with all the enterprise grade features. Thank you for joining my session.